It's the Q&A period.
There was no coffee.
There was coffee?
There was no coffee.
There was not. I did not see coffee either.
Hi, guys. Again, excellent talks. Thank you. Tim Frazier from Oracle. This is not a technical question, but it's something that I've been wondering about, and I'm interested in your views. You know, these laws that we're seeing develop in, it seems primarily Europe, but you know, also in the States, where data has to stay in country. Those seem to me to be obsolete in the face of ubiquitous encryption and all the great things that we can do with technology. So do you guys see those things going away? You know, if as an industry we can agree on standards that address people's concerns so that, you know, this stops being an impediment to how we think about, you know, doing processing on the cloud?
I'll try.
I'll do a shot of this from because I touch a number of the clients that do that. I'll sit down and because now I'm my presenter self, right? At this point, there isn't a good way of doing the endpoint governance. So that means we don't have geo-encoding for where you can do your decrypt. So there are a number of different solutions out there to say, I take an appliance and I take some S3, I take some Azure, and I take some, you know, digital, and then I erase your code across the three providers, and so I can never decrypt on the outside. Weird solutions like that are starting to show, but.
So I think where we are is that the governments are technically savvy enough to cause harm, or they think they're protecting their customers because, you know, they realize there is a problem, but they're not savvy enough to steer us towards a solution. Even if there are technical solutions for that, obviously, but it's much easier for a government to say the data needs to be in Germany, and that's it, right? If you try to go to German parliament and convince them that with this technology it's safe to actually store this data in America, we'll get there, but I think it will be at least another few years.
I mean, I would add from just our experience at Nutanix, we have, you know, good chunk of you know, revenue coming from federal agencies in United States, and yeah, I mean, there's a long road ahead, you know, before we reach a place where they're comfortable with data being not in their control. It's not even about the country; it's about whether anybody else has access to it. So, including the technology provider, we at Nutanix are not able to get our hands on the data. We can only look at a screen that's actually another screen, you know, it's a video of another screen and that kind of thing. And our support guys can only be on the phone, they can't see stuff. So there are some, you know, pieces of data that will probably never leave that data center. So there'll be probably, you know, grades of security over time.
And also see the different countries also seem to have different standards for how they encrypt and store this data, and that also plays into it because, you know, you can't really have, you don't really unfortunately have a universally accepted across all the countries in some sense. So we see this problem continuing to persist into the future.
Even the DoD has a private instance of AWS.
The Hadoop world has grown up on disks being integrated into the servers. And a lot of this conversation has been around segregating the disks from the servers and creating an architecture that's much more flexible that way. What is your prognostication about when the Hadoop world will adopt this new architecture?
So they already, this is one of the growth areas that I was also referring to during my discussion, is that the Hadoop will eventually has to adapt to these things. Like today, whatever the Hadoop distribution you use, getting a storage node added and recognized by Hadoop essentially is a problem that you have to solve at multiple levels, right? Some of the tool chain problems, you can automate them going into the future, but there seems to be a Java VM dependency. Essentially, you have to restart the Java VM to get the drive to be recognized. So there is a little bit more pathfinding work that's needed to overcome that issue before you get to a point where you can just throw capacity and it just grows on. It grows automatically there. I mean, so as a capacity planning tool where I say I'm going to run these services today and this is how they're going to be arranged and add one more node in there, I believe we are there. But in terms of just tossing in a high performance storage and saying, here, this alleviates your bottlenecks, there is definitely work to be done.
The hyperscalers have already kind of gone past the flip in Hadoop and have realized that the data set no longer fits within nodes, and so I'm still doing shuffles across the network. I'm still doing a lot more network work, and so they've effectively had to go to namespaces, Prism being the one, right? And the namespaces are then tailored for those particular job types. So if I can keep a namespace small enough, data localization is good and 3x replica is fine. But as soon as the namespace starts getting larger, I no longer have node affinity anyway, so I move to erasure coding and I cut my cost that way, and I go from having 2 10 gig uplinks to 4 40 gig uplinks, and I just take the cost in the network instead.
And I think there's a bit of distinction of decoupling of storage and compute on the software layer, on the hardware layer. And I think a lot of software within Hadoop, especially early on, wasn't even aware where the data was. It was in HDFS. So logically, that already existed, right? But then for performance, people started to observe what is where. So on the software side, it's very easy to decouple storage from compute. But we still need hardware to kind of catch up to really hide it and provide us with the performance where it doesn't matter.
Hey, following up on that note, I have a question on the hardware side. You mentioned keeping petabytes of data on S3 and then providing multiple data warehouses to access that data in minutes. How do you, the uplink between S3 and EC2, it goes over the network. How do you manage that? How do you overcome that problem?
The problem of the inception.
So if the data is in S3 and it's in petabytes, and then you're looking to process that data in minutes, and the link between them is still in gigabits, how do you overcome that problem at the hardware layer?
So there is no magic. We need to scan this data. What we can do is actually, this is a lesson I learned from gentlemen behind you. The most efficient way of processing the data is not processing it. So we rely very heavily on different forms of pruning. So to reduce the volume of data we need to fetch. And then we depend also heavily on the scalability of S3. So while a single node doesn't scale, you actually can get gigabytes and gigabytes of bandwidth from S3 if you use multiple nodes. But we actually did observe that for most of our users, the hotspot of their data does fit in local storage. So the first time they run a query, they observe some slowdown, but then it stays there and it's fast.
Ask a question for myself. So we've kind of gone from compute nodes with SAN fabrics, I think was mentioned in one of your talks, and HPC machines with separate I/O, to Hadoop clusters with co-located, and now we seem to be kind of going back. Is this just a cycle that repeats, or is this a permanent change now? And what is the real determining factor about which side of the balance we're on? Is it just network speed, or is it something else?
Yeah, I mean, this is the tick-tock that happens in terms of network versus I/O, right? Every time, I mean, you don't want to move the bits because moving bits is expensive. So that's where Hadoop said, no, I'm going to be co-located because I don't want to move the bits. And also, the pipes were narrow, so it was not practical to move the bits in some sense, right? Now, from 10 gig to 25, there is all the way roadmap to seeing 100 gig at this point. So network is getting to a point. This is why we're able to talk about NVMe or fabrics, for example. Because if the fabric wasn't was going to be a bottleneck. This would not be possible. So and that's what. And then we're going to invariably saturate that pipe, and then we'll go back and so I think they're in a race with each other in some sense.
Yeah.
Right.
Well, and I can test that race is going to kind of come to an end because we're not going to get faster CPUs. We're just going to get more cores, and so we're going to become bottlenecked at the PCIe fabric before we become end of roadmap for wide area fabrics. So there's always going to be some sense of how far can I hop. Today, you could say my 100 gig networks are effectively limited to sort of a 10-meter area. So it means my neighboring racks and maybe a rack or two in the next row, I can compost into one logical unit. And each of those racks, being 4 to 6 petabytes at this point, you're now talking about a lot of compute and a lot of storage in one of these quick compostable fabrics. You go the next hop beyond that, you say, I need to go down to 40 gig links in order to get to end of row. That becomes a choice. Now I'm not gonna put my NVMe device at end of row. It has to be within that initial compostable area. So those are the next challenges on defining the compostable hardware.
Yeah, I mean, one thing I would like to add there is, in terms of the compute and storage coming together, I think it's still happening. Basically, storage is going from spindle to SSD flash to actually going to almost memory speeds now with NVDIMM, 3D crosspoint technology from Intel. So the notion that persistent bytes are getting lower and lower latency is one of the reasons I see why storage is moving closer to where the compute is, where the CPU is. That needs to process it, because what the CPU hates is that it's twiddling its thumbs while storage is responding data. So these two have to come together. Now, what we are doing with disaggregated systems is actually, in my opinion, not going against this trend. All it's doing is providing the same fast bandwidth from the CPU to the storage, except that it's giving it to you in a form factor where if one of the components fail, you can swap in another one, while not having the failure domain be the whole sort of the node itself, node or the server. So it's helping reduce the collateral damage that happens when there is failure. But other than that, it's still actually bringing compute and storage closer together with high bandwidth connectivity.
So there is actually a data tiering. You see pyramid there, right? So as you go higher up in the pyramid, it costs more, but the latency tolerance is very small, right? And I think this is where when we talk about things like is storage moving to compute or storage being disaggregated and so on, I think we have to talk about all these things in context, right? If you're talking about some high performance, if you're talking about a cache layer, for example, like let's talk about processor caches. It only belongs in there because I'm trying to give you a nanosecond access layer. It cannot be farther away because the laws of physics don't allow it to be farther away, right? And same thing, right? If you get to why are we able to disaggregate a NAND-based NVMe drive today? It's because the access time for that drive is in the order of tens to hundreds of microseconds. So the networking latency has gotten to a point where that's maybe 10 microseconds. So it's in striking distance of being able to say, okay, I'm willing to tolerate that latency. And this is going to be an ongoing thing, right? Because you're going to invent new media that have different latency characteristics, and based on the latency characteristics, to what extent you disaggregate is going to be always going to be. This is why I talked about disaggregation within the rack and outside the rack, and maybe within the platform itself, because there are certain things you simply cannot, for latency reasons, cannot put farther away.
And also one last observation there is in the memory hierarchy, where you're storing application state, there are the first few layers which are non-persistent, and then after that you start, persistent layer. That persistent layer is going from spindles to very, it's more, transistor based and becoming faster and faster. Wherever the persistence layer starts, that's where the storage controller has to be injected, because that's where you'll take care of, snapshotting, replication, and all that. So that is the reason why the storage controller logic has to be pulled all the way to where the persistence layer starts, which happens to be on the servers today and also going into the future. So that's the fundamental architecture change that's happening, right?
Martin Kersten, thank you for the enlightening, actually, sales talks about hardware and how things are growing. It reminds me of some external issues I wouldn't discuss. But remember, below the crowd, there's the graveyard of data. Because when it's down there in the grave, nobody is going to dig it up, except when you know there is some really gold laying out there, but it's not true. So I would say, when comes the time we're making clear to our customers that why are you willing to pay for the graveyard? How cheap it might be. We should get rid of it. So that's one observation. The second observation, it's fine to have access, instant access to a petabyte of data. But who cares if you're doing ET or data warehousing algorithms? Because the only thing which is relevant is, do I see any statistical difference by looking about a megabyte out of this petabyte or the petabyte as a whole? So how can we make life easier for our users and cheaper and faster? But just giving the impression that they have statistically sound results available. So, any comments on that, guys, as salespeople?
So, a very controversial question. So, of course, you could argue that running a query that processes 10 terabyte of data rarely makes sense, and you have a point. At the same time, we see plenty of customers who require exact answers on this volume of data, and that's because there's money behind it. So, you cannot tell your customers, this is approximate to 2%. Many customers will not accept it. And also, some algorithms aren't amenable to sampling. I guess you're proposing sampling or pre-computation. Some algorithms are very hard to express with frameworks like that. But of course, you have a point. If you can, and there are plenty of algorithms, I think, for example, Pino mentioned hyperlog. If you can accept it, of course, you can do stuff like that. But your first question was about throwing data away, or?
You should have been at the last three XLDBs. It's almost the same tirade.
No. Well, you can read that the discussion on the ICD talk last week. No, we're talking about actually degrading cost. Yes, it got cheaper and cheaper actually to store a petabyte. It was about $100 a day. I think that was about the cost, but still that amounts to a couple of thousand. So there should be somewhere there actually a lower bound that people actually don't want to pay for garbage. So what's that point? And should we even not help them to avoid actually creating all that garbage and just saying, well, you better throw it away, even if it's $100 a month, because you have to summarize it, harvest it, or forget about it. And just be clear, go into your own cupboard and try to dig out that sales slip of 7.5 years ago about the Coke you bought at Safeways. You won't be able to find it. So why bother?
Right. So I think that's a choice that to large extent users make. And people store the data because storing the data is so cheap, they believe it has value for them. And if they can't pre-aggregate it, if they can't clean it.
But before Martin goes again, the cost curves are not going to continue dropping, right? If we're not going to get it 2 more TikTok cycles, we're not going to get new hard drives, we're not going to get a whole bunch of new things, that cost curve that you're looking for has to come by doing downsampling of data, by trashing data, by not ascribing false value to the things that we keep forever, like your Coke at Safeway for 4 years ago, right? This is a data governance issue, not
Exactly. So the government will actually intervene. The government already requires that data should be local because it doesn't allow pollution. Pollution is cheap. Buy actually a gallon of gasoline here. You pollute the environment. So it's data pollution all around us. So the government will intervene and stop you.
I will point out that the astronomers are often looking for like 1 in a million things, so you have to at least be able to pick those out first, so you keep them, even while you're trashing all the things that look all the same. Okay,
All right,
so
we actually
we actually have a few more now, so.
Oh, we got controversial after we ran out of our timer.
People don't want coffee.
How many more do you want to allow?
All right, first I'll try to answer his question since he has been asking it for so many XLDBs. The question is, how long do you store the data before it loses value? And I'm kind of in the middle. I don't think storing all data is bad, but as long as you can ask the business and business can tell you what data is fit for business purpose and when is the question that business struggles to answer that question. It's just not data governance. Well, that is part of the data governance. And it's a very hard question to ask the business. I have tried. Ask a marketing person. If they'll say, if cost is of no concern, store it forever.
So one day I was there working for Facebook, and we basically were running out of Hadoop space. So I started looking at who was using Hadoop space, and it turned out the lawyers had half, if not more, on legal hold. Right?
boy.
Because
Yeah.
any suit that comes in, you need to keep that state, right? So they kept state. And these battles would go on for months, right? So I merely simply brought the lawyers onto the carpet, sat them down, and said, how much is this going to be worth? Because this is how much you're costing me, and this is how much you're holding, and will you just settle this, or... So they actually went ahead and cut their usage by over 80% because they tailored now, they understood now, there is
Yeah.
a cost to the company to keep all of this stuff.
Absolutely.
And so
the
that conversation needs to happen.
The comment to the other side is when someone says storage is cheap, I would ask you to go to the CFO and ask for a budget. Then you'll figure out that it's cheap, but at some point you run out of money. Yeah. Anyway, to my question, we have talked about a lot of the cloud platforms. Obviously, Amazon, Google. You talked about 5 computers. I guess I can see who those 5 computers might be. But one of the challenges that the enterprises have is that all the tools that they have been using, whether on-prem or in the VM world, in the data center world, how do you propose? What's your point of view to speed up all these business tools, whether applications, databases, ETL tools? I mean, I can go on and on and on. How do you accelerate their movement to the cloud? That's a big problem.
Yeah, I mean, and that is a hard problem as well. So one thing is we need to create a platform that is becoming more similar to the public cloud on the enterprise side, right? Once we bridge the gap between what APIs you can find on premise versus cloud, then we can handhold the enterprise applications that are actually dependent on only POSIX APIs today, using not much from the next generation way of keeping state. If we can handhold them to jump onto this new way of building apps, then they'll be more portable to the cloud. But before that, it's actually very hard. The other angle there is you build a cloud that is more amenable to legacy applications. So Amazon, clearly is not there today. Even basic things that we take for granted on the on-premise side, which is vMotion, DRS, HA, those things are not there in Amazon. If we can build a cloud that is more amenable to legacy, that would be another way of moving them. So the two worlds have to come together. It's a hard problem, but something that should be at least attempted to be solved.
And there is virtualization on different levels. You can have kind of platform level, but you can have, one could argue, if you can virtualize the database separately from application or whatever is, applications are hard because they're very complex and very heterogeneous, but there is often common layer that they use, and databases coming from where I come from, of course, is one of these things. You can migrate things like these to the cloud, and even we actually have customers that have databases in the cloud and applications on premise, because the amount of data traveling back and forth isn't so big.
All right, let's thank our speakers. Thank you very much.